Hi, welcome to this introductory video on using Symbolic Python. I'm using the Python editor Spyder, which has Symbolic Python already embedded in it. This is a video series where I'm going to make videos as they're requested just to help people that are learning Symbolic Python. This is just a basic overview, and hopefully you don't have to have had any computer programming experience to understand. So this is the Spyder coding window. Over here we have programs we can write. Notice that this one is just called temp because I haven't saved it, temp.py. This is where you will write a program that you can save, turn into your classroom, or rerun somewhere else, or send that on the internet. This over here is kind of my help module. I have a variable explorer that's going to show me different variables that I can look at and see the variables that have been generated in my program or in my console. This is the console. This is where you're going to see printed output from your programs, but because it's Python, it allows us to interactively code. This is what I think makes Python so great, is right here, where I can be interactive with the program and learn things and change things as they go. Okay, so the first thing I want to talk about today is what is a function. A function is simply a collection of code that takes in input and spits out output. If you're thinking it sounds a lot like a function you learned in math class, that's because it is. Computer science is kind of built on the framework of algebra. So let's take a look at a function. But the first thing I want to do is I want to import my module. Because there's only the base module that's automatically imported, I need to import my symbolic Python, which is sympy. Now, if I import it as sympy, then I have to say sympy every single time I want to use anything from that module. But I could say from sympy import star, then everything from that module, I just have to say that I don't have to put sympy dot in front of it. Now, for many reasons, the star, by the way, is wildcard, means everything. For many reasons, though, this is not stylistically preferred. You might see it on lots of different tutorial pages and might be wondering, well, where'd they get that function? And I don't like it because it's not clear what it's coming from. Especially if you have multiple different modules imported, you won't know which one's from another. So another thing you will see is if you have, say you wanted to import just the integer class, you could say from sympy import integer, and then you don't have to put sympy just in front of the word integer. But what I'm going to do is some kind of a middle ground. I'm going to say import sympy as sim. And now I'm still referencing it in a way that people understand. I still have to put sim every time, but at least I've got it. So I just kind of shorten the name of it. All right. And now it's been imported. So let's take just a quick look at a function. A function, for example, the sine function, takes in a value and will allow me to compute things. For example, I could find the sine of, well, let's say 1 radian. And you notice that it doesn't want to completely evaluate it. But if I say the sine of 0, it should give me an exact value. So sympy doesn't want to evaluate things unless you force it to. Okay? Well, anyway, those are functions. That's the sine function. Now, there's a special group of functions that are called constructors. Constructors are obvious to tell because they have a capital letter. So if you see a lowercase letter like here, then you know that that is a function that's not a constructor. All right, so let's take a look at some constructors. I want to talk about the integer constructor. So the purpose of a constructor, and you can always tell a constructor because that capital letter, is to create objects. So let's make an object. Let's make an integer object. So I'm going to make, I'll call this in, okay? And I'm going to call it sim.integer. And you'll notice it brings up a little bit of help there for me. And so you can see that integer is what we call a class. Classes are for making objects, get it like a classification. And so you can see that I've got an integer now stored in. Remember, one equal sign is assignment. I'm not saying in equals. I really should say in gets assigned, or just in gets the sympy integer 36. So by review, remember, functions, lowercase, they just do stuff. We'll come back and talk about those again in a minute. And special functions called constructor have a capital letter and therefore constructing objects. Now, what exactly are objects? Well, an object in computer science is something that holds information, usually in two different forms. It has data that describe it, and it has methods that it can do. So we sometimes call them states and behaviors. The states are described by the variable. In this case, you can imagine that the variable might be the value of the integer 36. But it also has methods and behaviors. Technically, an object doesn't have to have a method per se, but most do, or it makes it more useful. And that's one of the really cool things about symbolic Python, is that while there are integers in regular Python, they only have like a couple methods. As we're going to see, integers in Symbolic Python have not just lots of methods, but lots of variables that are set, giving you super tons of information. So they're really powerful. So let's talk about some of the methods and variables associated with the integer object that I've created. So if you press in and then a dot, we always use a dot, the period, to associate. You can press the tab key on your keyboard, and it's going to bring up some options that we can use. And look at all this. It's really interesting. So the first one I want to talk about is function methods. So let's find a method. And so I'm going to find this eval f, and a method always has to have parentheses, just like functions always have to have parentheses. So I have to put parentheses at the end of it. Notice that I'm calling it on in, right? I'm calling my method on in, not on sympy. Okay? And so that's going to evaluate 36 to, I think the default's like 13 decimal places. Okay, not really very useful on an integer, I know, because it's just a bunch of zeros. But you could imagine on some other real number value that might be very effective. So you might be thinking methods are really similar to functions. And you're right, they are extremely similar. The main difference for you is that a function is called on the name of the module. So if I want to use a sign function, I say sympy, or in my case, sim.sign. If I want to use a function, I call it on an object. Remember, an object was something I got from a constructor, a special function that constructs objects. And so one of the things that I think you'll notice is, if you think about it, a function's always going to have something in those parentheses. I can't just say, sympy.sign and then have nothing in parentheses, because it's got no information. It says sign of what, right? But with an object, this eval f, that's a function. I didn't have to put anything in the, that's a method, but I didn't have to put anything in the parentheses because all the information was already contained in the variable in. Now, some methods do require you put something in parentheses. So methods could have one or two parameters that you have to give. So here's another one I want to look at. And by the way, you can skip the certain parts by starting to type in. Like if I say, I'm going to show you the least common multiple. If I put L and then tab, you'll notice it brings them up based on that. Really nice. I want to do least common multiple. So the least common multiple is the smallest number divisible by two numbers, right? So the smallest number divided by 36 will end what, right? Oh, by the way, if you didn't notice, there's my variable list. We talked about that earlier. So I'm going to say, well, what can I do? I'm going to put I have to put another number. So I could create a new function here, but you could also just type in an integer and it will work as well. So I'm going to give it, I've got 36. I think I'm going to do 24. Let's find the smallest number divisible by 36 and 24. Oops, didn't close my parenthesis there. And the answer is 72. So 72 is the smallest number divisible. So it used the information stored in, and then it used the information that I added technically as an argument when you call it, and parameter when it's waiting for it. So you can call this 24 a parameter or an argument and not get in too much trouble. So yeah, those are methods. They're called on an object. Well, objects, we said, also have variables. So let's take a look at some of the variables. in many programming languages, it is easy to tell the difference between variables and methods. Python, not always. The typical rule is that a method will be a verb. You know, least common multiple is not really a verb, but so they try and follow certain things but at least it's a command, it's an action, a call to action. But you really have to check the docs or just try it out. But things like those are typically not methods. Those are just statements of fact. So for example, I'll tell you what, let's take a look at, we already know it's an integer. We made this as an integer, right? But you know what? Is this a rational number? Is in rational. And it's not a method, so I don't put that. I just say inner, and it's going to tell me true. There is a function also is rational where you can put something in it. That's what it's saying. But so it's true that in is also a rational number, which means that it is a subclass of a higher class. So there's a rational constructor that creates rational numbers. Well, when we created an integer, since every integer is also rational, it knows that it's also a rational number, and so I can do all the rational things, including get values such as the p or the q, which you would think is only about a rational number, right? So, we can get the p value, well, that's 36, and we can get the q, which is the denominator, and you'll notice that it's 1. So it is a rational number because it has a numerator called p and a denominator called q, right? So that's pretty cool. There's some information I think it's just super cool. One of them I really like is composite. So that is a quick way to tell if a number is prime or not. So this one is not prime. It's a composite number. There's other ones as well, like is even, is positive, is negative, things like that, which is really cool. So these are variables that are assigned to it. These data variables, they don't have parentheses, unlike the methods that do. Okay. Now there are other classes besides integer. Obviously, we've talked about rational. There's a function class for making functions. There is a symbol class for making algebraic symbols like x and y, and there's an equation class for making equations. So those are the ones that I would be most interested in. So I can do sim.eq, and if you arrow your cursor in front and hit Control I, it will bring it up here in my help menu. Sometimes it links you to the documentation web page. Other times you can go in here and just try and, if you put it here in front of the E, it gives you something about the equality for the equation. It gives you just a little bit of help. So that's a way to look things up as well. So, but those are the key classes I would want to know. I would want to know the EQ for equation. I would want to know the function constructor for making a function. And then the symbol. So let's start with symbol first, okay? Since we really can't build equations without a symbol. So I'm going to let x be the symbol like that. So it's the symbol x, okay? It takes in what's called a string because it's got quotes around it. Okay, so now x is an object, right? It's going to have variables and things like that as well, right? And variables and also methods, right? We talked about that. Let's make another symbol. I'll make a y, okay? And this is going to be necessary when we want to write equations or take derivatives and things like that. So we can, now that we have x defined, we can do x times 2, which is how you raise something to a power in Python, and you'll notice that it gives me x squared. But Symbolic Python actually does something really cool. It allows you to have I love the combination of having linear math input, it's very precise, but having pretty print output, as I call it. So we're going to start that. We'll say sim.init for initialize printing. And I'm going to say, and you see you got all these options for how you're going to print. Pretty print true is one. I'm just going to say use, well, latex, that's nice. That's very pretty. So I'm going to say use Unicode and I'm going to say true. And true and false are called booleans. They are capitals letters to begin the true and big F for the false. Okay, so I've initialized using Unicode. So what we should see now is just a little slightly fancier output, and you can see it prints it like that, x squared. So we still enter it with x times 2, but it comes out looking really nice. So that's a nice feature, I think. We've talked a lot now. We've talked about methods and variables and how we use constructors. Constructors, remember, are special functions. You can always tell they have a capital letter, and they're for constructing an object of the class type of that name. So the symbol constructor makes a symbol object. We kind of glossed over functions earlier. We looked at the sign function. Let's go back and look at some other, what I would call essential functions to know. You have all your basic functions, your trig functions and things like that. But there's some others I think that you're really going to know. One of them would be the solve function. So this would be for using to solve algebra problems. Now the solve function, what it does is that it can solve an equation, or it can solve a polynomial that is equal to 0. So I'm going to say x times 2 minus 1, and I'll say solve for x. And you can see that it outputted -1, 1, because those are the solutions to that polynomial. Okay, but I can also create an equation object. So I can say, I'll call this EQ1, and remember, equation, you can just say EQ, and you give it a left-hand side. So I'm going to say x times 2 minus 1, and I'll give it a right-hand side of 0. Okay. And now we can go ahead and look at it. Now, if we were over here writing a program, we'd have to say print to see it, but that's a nice, pretty looking equation, right? Now I'm going to solve this, and I'll say I want to solve EQ1 for x. And so I'm giving it an equation. See, same result, so if you don't feel like setting it equal to 0, or if you're solving a multivariable equation, remember you can put in a different letter here than x to solve, we looked at some different things. Let's make another equation. Let's say equation 2 is equal to sim.equation. I'm going to say y squared minus x squared is the left-hand side, and I'm going to put 4 on the right-hand side. Okay. Oh, that's right. I'm sorry. You don't put equation. You just put EQ. All right. Let's look at that equation. Oh, that's equation 1. Let's look at that again. Oh, there it is. Right. You know what? Let's solve it. Right. So I'm going to say sim.solve. I'm going to say equation 2, and I'm going to solve it for y. Isn't that cool? It gives me 2 solutions because it got to take the square root plus or minus. Right. So that's really neat. I do want to talk about another thing. Let's take a look at this equation here. Sim.solve. I'm going to give it another polynomial equal to 0. And it's, this is x cubed minus 6 times x squared plus 9x. And you'll notice that I get the solutions of 0 and 3. But, we know that multiplicity when solving a polynomial is really important. It affects whether or not the graph bounces and concavity and things like that, whether the signs change. So Symbolic Python allows us to use the command called roots, which gives us just a little bit more information about it. And you'll notice that the root of 0 actually only occurs once here, but the root of 3 occurs twice. So we know that that is actually a repeated root. So we would expect the graph to travel through the x-axis at 0, but bounce at 3. So that could be important information. All right, so that's kind of how I would use Symbolic Python for algebra. We can also use it to factor. Just keep that in mind. X times 2 minus 4. There is a factor function, as you can see. So Symbolic Python can be used a lot for your algebra classes, but we need to make sure we're able to use this for calculus. And the 3 main parts of calculus, of course, are limits and derivatives and integrals. So let's take a look at a limit first. So limit is just is a function, again, just limit, and we can give it an equation like I'll use the sign function, the symbolic sign, so sim.sign divide by x. And the way we enter it is you have to tell it the variable that you want to take a limit as it goes to, and then we'll give it the number 0, and so that should be 1 if you remember your limit rules. Let's do another one. 1 over x from x to 0. So that limit is an infinity, right? But we can actually tell which direction to come from. So I'm actually going to say come from the left, okay? And you'll see it's a negative infinity. So take note that really the limit 1 over x as x goes to 0 should really be, does not exist since it goes in two different directions, but it went ahead and resolved itself to just telling us an infinity. So be careful about that result there, that infinity. You want to tell it, you can type in the left, and you can change that to quote plus to come from the right to make sure that you know which one. Whether or not it really did exist, okay? Let's see here. What else do we need to do? Well, we need to be able to take limits at infinity, right? So let's take a look at that. I'm going to take a limit of the exponential function, which is exp, very common in programming, the exponential function, so sim.exp. And I'm going to do the exponential function as x goes to infinity, which is actually double 0. So it's double O, because it kind of looks like infinity. So sim, and then lowercase o, not 0, sorry. Let's see what that goes to. Well, that goes to infinity, because e to the x, it goes up forever. But if I put a negative in front of it, e to the negative infinity should be 0. So that makes sense, right? Okay, so after limits, we need to make sure we know how to do derivatives. So let's take a derivative. That's just diff for differentiation. Couldn't be easier, right? I'll give it my sim.cosine of x. I think we know what that should be. That should be negative sign. And it sure is, right? Let's do sim.exp. One thing I should point out. Notice I didn't tell it the symbol. If you only give it variables with x, it should automatically do x. But I could also say sim.exp x times 2. I can actually tell it with what variable I want to take the derivative of. So, for example, let's say I had a y times that. Well, then that y, when I take the derivative with respect to x, is going to be just coming along for the ride. It's a constant. But if I take the derivative with respect to y, well, then I'm going to get, e to the x squared, because the e to the x squared is now a constant. So when you start taking partial derivatives, you're going to want to use that command as well. We need to make sure that we're able to do integrals, and they are also super easy to do. You just say integrate. And I'll say sim.cosine of x, and you'll notice that it integrates, but I can also tell it with which variable to integrate with respect to. So that should be sine x, but if I told it a y, you'll notice that cosine x is a constant. So it's just like 2, and the integral of 2 would be 2y if it integrated with y, so it just puts a y there. Those are just barely touching the surface. Obviously, vectors and things like that are going to be an important part of this whole story. And we didn't work in any programs, but I hope that helped you get started using Symbolic Python. If you have any ideas for future videos or things that you'd like me to research for you and make a video about, let me know.